Alright guys, looking at today's lesson, what we're going to be looking at is how to find the area of a regular polygon, and it's a very simple process. There's a little bit of trig involved, which is why we had to do the right triangles unit before we continue down with the area unit. Simply put, the area of a regular polygon is 1/2 PA. The P represents the perimeter of the polygon. The A, on the other hand, represents the apothem. And we talked about that a little bit earlier last week. So when we look at the apothem is basically from the center of the polygon and is perpendicular to the side of the polygon. We call that the apothem. And now you might be thinking, okay, 1/2 PA, that's kind of a really strange formula to be using for area of a polygon. But when we really look at it, it's not really that amazing. Because if you notice right here, when I draw what we call the radii of the polygon, so here's our radius, and we have another radius over here, we actually are creating a triangle. So when you start thinking about it, you might ask yourself, well, how many triangles do I have? Well, if I keep drawing my radii, that gives me 1, 2, 3, 4, 5, 6 triangles. Now what's interesting about this is that I have a hexagon which has 6 sides. When I draw the radii, I get 6 triangles. So if I have a decagon, I would have 10 triangles. If I had a pentagon, it would be 5 triangles. So the number of triangles that we get is equal to the number of the sides. Now as we keep going on with this, we start looking at it from a different perspective. The area of the entire polygon is the area of each one of these small triangles. Well, how do you find the area of a triangle? Well, if you remember from earlier, the area of a triangle is 1/2 its base times its height. If we label the base side 1, side 2, side 3, and so forth, all the way up to side n, then the sum of those triangles will equal the sum, or will equal the area of the polygon. So what we get then is the area of each triangle is the base, which is side 1, and then the height of the base is the apothem. In fact, if I draw all my apothems, they're all the same length. So these are all going to be A. So therefore, it's 1/2 side 1 times A. But I actually have a whole bunch in there. So what I really get then is, I'll actually just here at the bottom, the area is 1/2 side 1 times A plus 1/2 side 2 times A plus 1/2 side 3 times A plus, and it goes all the way up to plus 1/2 side n times A. Now one of the things I want you guys to notice is, what does each term have in common? You'll probably notice that each one has a half and each one has an A. So we can factor those two things out. And so what we get is the area is equal to 1/2 A times side 1 plus side 2 plus side 3 all the way out to side n. And then you might ask, okay, why does that look familiar? What does that represent? That is the perimeter of our polygon. So that's how we get to area is 1/2 PA. Okay. So very simple. One of the other things I want you to notice is the radius. Okay, so I want us to kind of come back to this whole thing right here, and I want to talk about the radius. What do you notice about the length of both of those radii? Okay. Well, it's similar to a circle. The radius is the same for all these triangles. Each one of those radii are the same. So in fact, what did I actually create right here? And some of you guys might be saying, well, that looks like a equilateral, but more importantly, it's an isosceles triangle. And some things I want you to remember from an isosceles triangle is that if you have the altitude of the isosceles triangle, it bisects the vertex angle. Okay. Now, this is where I need you guys to think a little more for me here. Understanding that this apothem bisects the vertex angle. If I connect my dots, what shape did I create? And you guys should say, well, hey, that looks like a circle, which you're correct. That is a circle. Well, how many degrees are in a circle? And there should be 360 degrees in a circle. And then notice, well, if I take that circle and I cut up into parts, how many parts do I get? I've got 1, 2, 3, 4, 5, 6 parts. Which again is back to the type of polygon we have. If I have an octagon, I'd have 8 parts. If I have a decagon, I'd have 10 parts. So to find this value, all you do is take 360 and divide by the number of sides. So the angle here is 360 over 6, which is 60 degrees. Okay, so the vertex angle in that triangle is 60 degrees. But remember, the apothem bisects that angle, so therefore it's 30 degrees. And now we can use trigonometry, knowing the side length, which also gets cut in half, so the apothem actually bisects the base. Now I can use all the trig I need in order to find the apothem, and then I can plug that into the perimeter. Okay? So let's actually go forward and we'll try this problem here. We have an octagon with side lengths 12 inches. So we're going to draw our little octagon here. And it's going to look really bad because I suck at drawing. But that's okay. So there's our octagon. And then I'm going to draw my radii. Now remember, since it is an octagon, and our side length is 12, if I draw my apothem, what can you tell me about this length right here? How long is that going to be? Remember, the apothem bisects the base. So therefore, that length is going to be 6 inches. Okay, now the question is, okay, if I need to find my apothem, I need to know about this angle right here. Well, now let's remind ourselves. The vertex angle, which is the whole angle, okay, so actually I'm going to do this again. So we need to know this angle right here, and the vertex angle, which is the whole angle, is 360 over n. So in our problem we have an octagon, which means 8, so 360 over 8, which comes out to be 45 degrees. So my whole angle is 45, but this little portion is half of that. So that means that is 22.5 degrees. Now, let's look at this triangle a little closer. Well, let me redraw that a little bit there. Some problems here with my technology, as usual. Alright, so let's try this again. So I'm going to look at it a little bit differently. I'm going to look at it from a side profile rather than vertical. So what we know is that this is 6, this is A, and that's 22.5 degrees. So now we ask ourselves, okay, what trig function am I going to use here? Well, I have the opposite, and then I have the adjacent. So which trig function is that? Well, that's tangent. So then what I have is the tangent of 22.5 is equal to 6 over A. And then remember, when the variable's on the bottom, you just swap them. So A is 6 over the tangent of 22.5. Now at this point, I wouldn't go to decimals quite yet. We will, but just not right now. You don't want to do decimals until you're ready to finalize the entire problem. So you keep everything in the exact format until you're ready to go to decimals, which is the very last step. So now, let's go back to finding the area of a polygon. The area is 1/2 PA. So first question is, what's my perimeter? Well, each side is 12, and I have 8 sides. So that's going to be 96 times 6 over the tangent of 22.5. And guys, this is the expression that you would type in your calculator. In fact, if we do that, and I don't have my calculator up and loaded, so I'm not going to go to that because that takes a little bit of time. So I'm using my handheld at the moment. But if we take 1/2 times 96 times 6 divided by the tangent, 22.5, we get an area of 695.29 square inches. And there we go. That's how you find the area. So, just in case you guys are curious, that's how we do it. So, that's the end of my video. Have a good day.